If you don't know Tormach, we're a pretty small company, about 40 employees. Most of us in Madison, Wisconsin, but several of us distributed throughout the United States and even a few international. And we're 100% employee owned. Our mission is to help people make things. And we do that mostly with computer controlled machining equipment. So you see kind of our main product line here, milling machines, a lathe, a surface grinder. We added a couple of new ones just in the last 12 months here. That's a wood router, CNC router, and a plasma table. So new additions to our lineup here. But of course, you all are interested in a different type of robot, I think. All of our machines have a control that we have built on top of an open source project called Linux CNC, and it's been a fantastic collaboration. We've gotten a lot out of it, and we've been able to give a lot back to the Linux CNC community. And that plays into what I'm going to discuss next. Linux CNC is a fork known as Machine Kit. All of these projects have their roots back with NIST, and Fred Proctor, who I think attends some of these meetings, wrote the original code or chunks of the original code that controls our machine tools. The community took over from NIST in 2000s, and in 2010s, Machine Kit fork was established to get away from just 3-axis CNC machine control. And you can see these two projects are quite flexible. They're entirely Linux, and they're built on real-time operating systems, right now RT preempt. And they're large enough that there's a decent availability of kind of external support, the hardware cards that help you interface these things. An example of which is shown there on the left. And the main popularity behind Machine Kit and Linux CNC is CNC retrofits. So enough of the background of Tormach, and on to what I wanted to talk to you today about. I guess the first question, why would Tormach create a robot? And the real reason here is we had such a positive experience working with Linux CNC, and we found a lot of value out of that relationship, that when I encountered ROS for the first time and went to my first ROS meeting, I was just blown away. And I thought, boy, if we could do something like we did with Linux CNC, but with ROS, we're sure to find some opportunity. The other reason here is just to help people make things. We've got, our mission is to help people make stuff. And I don't think people think of a robot as helping you make things, but you can imagine I'm sitting in a 2-car garage here in suburban Madison, Wisconsin. And you can imagine walking into a 2-car garage, and instead of finding the minivan and a couple of bicycles, finding a milling machine and a lathe and a robot cooperating as a work cell. And if such a cell were available to the citizen machinist, the citizen robotist that Lou talked about earlier, instead of only being available to GM or Ford, if we could make that stuff available to normal human beings, we might be able to bring cottage industry back to the United States. So that's the other goal here. We did this because we were enamored with ROS when we saw it. We had a great experience with a different open source project. And the secondary goal is to further the mission of the company to help people make things. So we started this project about 3 years ago, and we're to a point now where we have 10 of these things sitting in our warehouse looking for beta customers. We're going to do a beta program with people for the next 8 months or so, and then we plan to start selling these to the general public in June of 2021. So I want to give you a quick overview of this, and then I'm going to hop over to the Linux computer that controls the robot, and we'll poke around at the interface and move some stuff around. But real quick, it's a standard industrial robot. It is 6 kilogram payload, uses harmonic drives and servo motors, EtherCAT, 16 channels of input and output, almost a meter of reach, and it is controlled by ROS under the hood with our user interface PathPilot on top. Now, there are a lot of 6 kilogram industrial robots out there, you know, FANUC and KUKA and AVP and Yaskawa and UR, and it just, you know, the list grows almost every day. So what makes ours different? The price, I hope, makes it different. It's quite a bit less expensive than some of the offerings from other folks out there. I know that an average industrial robot you can purchase bare bones for maybe 20, 25,000, but most people end up spending 30 to 50 or beyond when they've actually installed the thing. Another differentiator here is the ROS integration. So, and I know Heiss is on this call, and I know some of our developers have talked to him, but my understanding is that the drivers that are available for most of the commercially available robot hardwares out there are like a 60 hertz driver. We've got a 1 kilohertz control loop, and we expose every parameter from the robot back to ROS via the hardware abstraction layer in Machine Kit. Another interesting thing we'll cover in a second is the robot programming language is Python. So not Carol, not UR script. We didn't find a de facto standard, so we decided to go with Python. And when I say Python, I mean vanilla Python. So you can write any Python code into a robot program. The robot, we sell a lot of CNC machine tools, so we clearly wanted to integrate it seamlessly with our CNC machines, and you'll see an example of that in a moment. And lastly, we have a technical support staff that actually will talk to you, unlike some of the folks at FANUC that are a little hard to get a hold of at times. So we plan to support this robot the way we support our milling machines. That is to say, we pick up the phone and actually talk to you and help you out. So I'm going to bounce over to another screen here in just a moment. Okay. What I can't tell is how many of you can see both the screen share and the robot behind me. Hopefully, hopefully you guys all have a window of both. If you don't, I encourage you to put Zoom into a mode that would allow you to see the robot behind me. But
looks good from here, Daniel.
Great, great. So I'll run through this real quickly. Folks that have used, I don't know if any of you on the call are familiar with Tormach or if you've used any of our CNC equipment before, but if you have, this will look extraordinarily familiar to you. PathPilot's our CNC user interface, and I can confidently say it's about the easiest CNC user interface on the planet. It consistently gets high marks from the folks that do surveys and ratings of CNC applications. It's super easy to learn. And we've tried to make this as close to the CNC user interface as possible to get our users feeling very familiar with it. So you see some program controls here down at the bottom. You've got position readouts here in both world coordinates and joint coordinates. We've got some jogging controls. Up at the top, we've got files that you can access and load in the file system. We've got offsets for the, this would be user frames in KUKA's world. We call them work offsets. Settings for the machine, and a lot of conversational programming capabilities that I'll get into here, and then jog screen. So I'm sure you can, you can perhaps see the machine behind me. We can jog this thing in joint mode. We can go ahead and drag a marker around and we can move the robot to the marker. We can jog it in Cartesian coordinates, right? So, and the Cartesian coordinates could be in step jogging or in continuous jogging. So we've made it fairly easy to move the thing around. I'll show you real quick how easy it is to program it. We can drop a waypoint, right? I could then move the machine to a different location, drop another waypoint. Then I could run over here and I could add these 2 waypoints to a program. Save that program. I'll overwrite that. And now you can see the robot doing its thing. Maybe slow it down a little bit for the purposes of this demonstration. But of course, we could easily add, you know, gripper, vise, opening, closing. Any of the I/O pins can be accessed conversationally. We could add those, you know, add that command to the program. And I can reorder them. I don't have my compressor on, so you might just hear a relay click. I could add a wait command in. Of course, I could just wait for a digital input to change state. I could put in an optional pause or a pause. I can notify the user with something like, "Hi, Matt. And so you get the idea of how easy it is to make these modifications here, right? You know, let me get rid of some of this stuff that we tossed in. I mentioned earlier that we make it easy for folks that have Tormach machines. I'll just bring the milling machine into the scene here, and you can see behind me the robot is sitting next to my mill. And in fact, I've got this set up, and now the mill is in the collision model. And if I wanted to, I don't have the mill on. I probably should have turned it on, but if I wanted to, I could come in here and I could tell the mill to start a cycle. I could ask the robot to wait until the milling machine is idle. I could even select different instances if I have more than one Tormach machine connected. All this happens over just a network cable. I can issue arbitrary MDI, as machinists speak for manual data input. So I could issue single lines of G-code commands to the milling machine. And then we have subprograms and control structures, if else, loops, variable assignment. You know, we've got a whole lot of stuff. But one of the things I wanted to show you here was, well, I guess 2 things. Let me start the cycle on this. Sure, we'll save it. So you can see the robot moving, and you can see it moving behind me. Actually, I'm going to change. Give me a second. I'm going to change the program here so that we've got a little bit more dramatic of a move in J1 here. We'll add this one in. And then I'll add that to the program. And I'm going to get this running here. So I mentioned that there was a very tight control loop, right? What I'm looking at here are the actual torque values or position commands or drive feedback commands. So I look here, I'll bring the position down on this so you can see it a little bit better. That's the joint position command for the 4th joint on the robot. What we're looking at here in red is the torque on joint 2. So if I stop this robot here for a second, you can see not a lot of torque on joint 2. If I come over here and I lean on the robot itself, right? So you can see that the robot, in fact, I think I may have just faulted it. You can see that the robot torque gets communicated right back to ROS in real time, not at a 60 hertz update, but at a fairly fast update rate. It didn't expect me to be pushing on the joint like that. And so this is one of the neat features. Any of these variables that exists in here, any of the motor parameters, any of the offsets, the following errors, the torque, the scale, you name it, all this stuff is exposed to ROS, right? And so when I'm sitting here looking at the torque value in this joint, as I press up and down on it, you can imagine what you might be able to do if you could bring that information back in a super flexible way. That's one of the things I wanted to show you. The other thing I wanted to show you was how neat it is to have a robot that interprets just regular old Python. So here I am here. Shoot, let me open that file we just created. Open, where was it? Robot programs. I think we named it test. So this is the program that we just created. And it's regular Python here. And so you can see we've created an API for it. But because it's regular Python, we can do all sorts of stuff. So a couple of weeks ago, I was trying to train the robot to pick up some jaws from a special pneumatic vice system made by folks called ROS-Based. And their jaw set is a really neat thing, but it's spring-loaded, and it requires this sequence of moves that's just really tricky. And I was trying to train the robot to do it, and the robot was just kind of flying through it, and I couldn't tell which step it was at. So I said, you know, I just want the robot to tell me where it is in the program. I thought, well, this actually shouldn't be that hard. So I wrote, you know, a handful of lines of Python. I brought in the Google text-to-speech library. I brought in MPG 321 and wrote a little wrap around it. And now I can say from robot speech, import speak. And then if I wanted to here, I could say something like, I don't know, what do you know, hello, ROS enthusiasts, right? I could save this, I could bring this back over here. We'd love the thing.
Hello, ROS enthusiasts.
I mean, the robot's pronunciation isn't all that good, but you know.
Hello, ROS enthusiasts.
So you get the idea of how flexible stuff is. You know, Lou showed that great little demo from Highwind with the robot that responds to voice commands. You can see if you know a little bit of Python, it wouldn't be all that hard to get this robot to respond to a voice command. In fact, that'd be a pretty cool demo. It's something I should take a look at down the road. But you know, the flexibility of Python really makes this quite cool, because any Python program you might write can be a robot program. So, you know, another quick example, I've got, I brought Twilio in earlier, and I set up my account ID. Oop, better not show that to the screen share. And I had a program running where every 100 times it operated, performed this operation, it would send me a text message. And, you know, it's like 15 lines of code. So very, very flexible stuff. Let's see, I'm gonna stop the share on that screen, and I'm gonna come back over to this one. And I see there's some chat. PathPilot software is open source, +1 for the live demo. I love it. I'm gonna share screens here. So I think we covered the control loop, the 1 kilohertz control loop. You saw all the machine parameters that get back to ROS via HAL. Those are all available from the Python program too. I should have mentioned that. It's very easy to grab that information and bring it right into Python. The robot programming language is Python. We kind of hit that. It works natively with Tormach machines. So last, I want to hit future work. So we developed this thing first to be able to do something pretty useful. So we wanted a 6 kilogram unit that was accurate and able to tend a milling machine. Milling machines are our bread and butter, so that was a natural fit for us. But it occurred to us as we developed this that I don't know if any of you have ever been involved with trying to teach someone how to program a computer. I used to teach some programming at the University of Iowa at the engineering college, and I've tried to teach my kids Python. And I can tell you, it's so much easier to get students interested when typing lines of code results in something in the real world moving in physical space. So, you know, we used to teach Hello World at University of Iowa, and boy, kids just weren't getting into it. I can see teaching Python with a smaller version of this robot as being a really, really neat tool. So we're working with a guy named Chris Annan, who has an open source hardware design called the AR3 robot. We're working to develop a stepper-based version of what you see behind you. We also have almost finished a web-based simulator, which would allow you to use this interface with a simulated robot just by signing into a website. And then we're not sure what future work is going to bring, because I don't know how people are going to use this. We've been trying to find beta customers to help us get over the last bevy of bugs and provide feedback to us. And we're still looking for folks. If you're interested, please let me know. But the handful of beta customers that I've talked to, not one of them wants to tend a milling machine with it. So we'll see how people actually use it when we send it out into the world, and we will prioritize our future work based on their feedback. So I had some questions about the user interface and open source. So the PathPilot CNC user interface is open source. You can request the code for it. We don't have it up on GitHub. There's a slight barrier to entry there, but we do send it out. Also, all of the underlying motion control code for our CNC machines is open source based on Linux CNC, and we push back any improvements that they will accept to that code base. This ROS work that we've done, the ROS-HAL connection is open source and it's available up on GitHub. So people that know HAL, know Machine Kit, and know Linux CNC can grab that and play with it. We have not yet open sourced the GUI. We're still thinking about that particular issue. But by and large, we're happy to share the work that we do, and we push whenever we can, especially if it's improvements to move it or to jog arm, stuff like that. We try our best to get folks to accept that upstream, because we don't want to maintain different forks. So that's what I have, and happy to take questions if people have.
Oh, it looks like you got one in the chat.
Yes. Heis, if you have people that you think would be interested, not only do I want to sell to universities and researchers, what I really want to do is get a couple of them signed up for our beta program we're doing. I didn't talk about the details of the beta, but basically, if people are interested in helping us develop this over the next 6 months, helping us test it, providing feedback, criticizing it, what we're doing is we're offering them use of the robot for free for the next 8 months. And if they want to keep it after 8 months, they would pay us 75% of that $16,000 price tag on it. So if you have people that you think would be interested, please send them my way. I'm happy to Zoom with them and work through everything. I think this would be, from the couple of universities that I've talked to, people seem very interested, and we're really interested in getting this into universities. I'm on the advisory board for the University of Iowa, which is my alma mater, and they have a KUKA robot that they purchased at great expense to teach their engineering students, and it's been a disaster because other than training it to pick up a cube and move it from one place to another, they haven't really been able to teach with it. So yeah, well, perhaps I'll follow up with Heis. Maybe we can chat on email or something after this.
Excellent, Daniel. I appreciate it. Thanks for taking the time out of your day. I know you had to kind of step out and step back. So
yeah, no problem. No problem. Thanks again, Matt. I really appreciate it. Take care.